is nothing. That's just a small word that people use far too often. And if the US Navy can do it, we can for sure do it. Okay, so I hand over to the MARSEC team. We have a lot to say in a short time. So please go on, and we'll see how it goes.
So thank you very much, Geir. Good morning, everyone. We are going to present MARSSA, which is the Marine Systems Software Architecture. Next slide, please. So basically, I'm Annalisa. I'm part of the MARSEC-XL team, and I will be giving an introduction to the marine industry and to MARSEC-XL. And my colleagues here, Zach and Ellen, and also Clayton, will be presenting MARSSA. So the marine industry basically sustains some of the most complex and diverse both leisure and transportation vehicles in the world. It can broadly be divided into two segments, the commercial segment and the leisure segment. We are looking at a total of around 30 million registered vessels worldwide, out of which 60,000 belong to the commercial industry. These vessels contain a lot of sophisticated software-determined devices. Through studies carried out by MARSEC-XL, entitled Lock Per Foot in 2009, it was determined that an average 32-meter yacht, such as the one you can see in the picture, contains around 5 million lines of code. And through the study, it has been determined that it is predicted to increase tenfold by 2015. The marine industry is also highly fragmented, where we have a few key players, but thousands of SMEs. So basically, we have identified some deficiencies in the marine industry. For example, most marine electronic systems operate on proprietary networks. There are too few standards, and this leads to problems of integration and interoperability, which in turn limit the competitiveness and also innovation, and lead to a high total cost of ownership, as Mr. Womble has previously mentioned. Also, in the marine industry, we have old and inadequate business models and a lack of living labs. Another factor is that we are missing competencies and focus on system software engineering, which is quite a significant deficiency when considering the important role of software in the marine industry. So basically, after identifying this lacuna in the marine industry, MARSEC-XL, which is the Marine Systems and Software Engineering Cluster of Excellence, was set up in Malta in 2007 with the mission of driving and shaping the future of the marine industry. Basically, MARSEC-XL consists of 4 entities. We have the first entity, which is MIC at Malta, the Marine Institute for Software Engineering, and it deals with the research, and it is the Research and Education Institute within the cluster. We have the Super Yacht Technology Expansion Center Limited, which is the testing and experimentation living lab in the cluster, and also Marine Business Port Limited, which is responsible for the real estate facilities of the cluster and also hosts the development of new companies within the cluster. And last but not least, the MARSEC-XL Foundation itself, which oversees the development of the entire cluster. These 4 entities operate under the unique work model shown in the picture based on the principles of open innovation and open business model. So basically, there is a complete and unbroken sustainable innovation chain ranging from research to testing and experimentation, and finally to productification and commercialization into the market. So MARSEC-XL is adopting a sound software engineering methodology to research and development, prototyping, and also commercialization of marine software systems. Here we can see our focus areas, which range from the entire navigation, communication, infotainment, etc. And innovation plays a key role in each of these sectors. Basically, the ultimate aim in all our projects is to create vessels which are more user-friendly, more economic, greener, and also safer vessels. So, in summary, we can see that the marine industry is becoming increasingly software-determined. However, surprisingly enough, very few players are realizing this. So MARSEC-XL set about educating and raising awareness about this fact. Another thing is that many of the deficiencies which I have just mentioned in the marine industry are the result of a lack of a common reference architecture. So as Gary previously introduced in this session, last February we launched the first open reference architecture in the marine industry, which is called MARSSA, as a community-driven initiative. And my colleague, Zach, who is the MARSSA project lead, will tell you more about this.
Hi, good morning. Welcome to the MARSSA project. So in the next couple of minutes, I'll drive you through the MARSSA at a high level, how we're driving this open source project, and the details, we'll dive into the details of the MARSSA reference architecture. My name is Zach, and I'm a keen sailor, so all this is my passion. So seeing technology advance on yachts and on sailing boats is why I'm doing it. So if you look at let's say you look at the normal super yacht outside, or these boats, the Rolex or the Sea Race, the naval architecture is very visible. You can see the structure of the boat, the ship lines, and everything. As soon as you step on board, you see the interior architecture, the furniture used, the interior, and these things. Whilst the marine system software architecture, what platform the boat is running on, its engines and electronic systems, is very hard to see. And we've noticed that there's a lack of such a platform. So we've come around with MARSSA, Marine System Software Architecture, the first open reference architecture of the marine industry. So MARSSA, in a nutshell, its mission is to reduce the total cost of ownership on board a boat, whilst our vision is to be the de facto platform across the marine industry. Now, MARSSA, as a project, is open source and community driven. So it's under the umbrella of the MARSEC-XL organization. So MARSEC-XL as an entity is driving the MARSSA project. Now, we've launched MARSSA 6 months ago. And from that date till now, we have a community of around 100 members. Now, if you compare that to most software engineering companies in Malta, we've already passed them. So in 6 months, we've grown bigger than most IT companies on the island. So how are we driving MARSSA? So MARSSA, as I said, 6 months, we have 100 active members. It's an open source community, so anyone in this room or around the world is able to join the community online, marssa.org, and help us contribute, such as if you're a ship owner, a yacht owner, or you're a software engineer, and you see, like, I want this new technology on board. You can suggest it in a forum or on the wiki, and we'll be able to, the community of members around the globe, push it forward. So let's say in our next prototype on the demonstrator, we'll have, let's say, an intelligent berthing assistant that a client wants. And together with the community, you'll be able to push it forward for you. So MARSEC-XL is driving the MARSSA project, which is driving a community. So the community is everyone around the world, which is part of this community. We have MARSSA, we have wikis, forums, a monthly newsletter, we have a video scribe, and we have meetings. And together as a community, we're driving the MARSSA project. Now, in order to create some form of governance in this project, we have a technical steering team, which is led by the MARSEC-XL, over a set of members on this team, which creates some form of guidance. And so we say, next month, we're going to focus on this. Next month, to focus on this. So we say, we push out a request to the community and say, what do you think we should focus on the next month? And they say we should focus on hybrid systems. So we'll get the community engaged and interacting to focus on this. So now, we're going to dive into the reference architecture. So we've been talking about open architectures and reference architecture, but in actual fact, what is a reference architecture? So let me give you a comparison. So if we go to when we're building a house, the workmen don't wake up one morning and say, let's build that house. No, they first go to the architect, which comes up with a blueprint, an architect of how the house has to be. So that's what we've done with MARSSA. But we haven't created a plan for one house. We've created a plan for all the houses on Malta, let's say, where each architect in Malta is able to take this hybrid, high-level plan and create his own plan for a house from it. So we have a reference architecture, which an architect generates a system architecture for a particular product and designs a particular system which is then deployed in a boat. And it's very important to notice that there's a backwards loop all the way. So as we create more instances of MARSSA, it's always being improved and upgraded. So in order to represent such an architecture, we have to come up with a methodology so everyone will be able to understand it. So we used UML, which is like a language which allows people in the IT industry to talk on the same level, using the same language. Because if we talk in English, like if I say hi and you say hi, but for both of us, it might mean different things. For you, hi might be 5 knots of wind, but for me, hi might be 10 knots of wind. So we use UML in order to have a standard language to reduce ambiguity. Now, MARSSA as a reference architecture, so let's say this is MARSSA, this ball is MARSSA. everyone around the room is looking at MARSSA from different viewpoints. We'll have me looking at the board from here, Gary looking at the board from there, and let's say Emmanuel looking at the board from there. These are all different viewpoints. So we've mapped out MARSSA with various viewpoints, each representing the same architecture, but from different angles, so that different people in the industry are able to understand it being a business guy or an IT engineer. So for the first version of MARSSA, went around and used regulations such as DNV, ARENA, and as well as market data and regulations and market trends. And we came up with a set of scenarios, around 50 scenarios, which are then encapsulated in the first version of MARSSA. And that's how a typical scenario looks like. So now, one of the views is called the module view. So the module view will have, let's say, hardware. That could be an Intel processing chip. Above it, we have a hardware virtualization layer, and we have the MARSSA middleware, the engine, the domain and usage-specific services, and application and services, as well as the MARSSA security. Now, as you can see, that the MARSSA reference architecture is technology independent. So each of those building blocks could be built up, let's say, with Google technology, or with Microsoft technology, or with Linux technology. It depends on who's going to instantiate the reference architecture. So that's at the same view, but looking at it from a different perspective. We have MARSSA as the platform. I have different applications running above it, such as a route planner. We have motors, sensor data, infotainment. These are all, so we have MARSSA as the platform and services running above it. So everyone, it's like saying MARSSA as an iPad, and we have different apps running above it. So we've created an iPad, the MARSSA platform. Now, above MARSSA, we have different applications running. And that's how we represent it with UML. So scientists, professors in the IT industry are able to understand it and help us push it forward. Now, that's one view. Now, another view is the publish and subscribe view. So in order to create high cohesion and low coupling, what did we do? We came up with the MARSSA reference architecture. Each component can't talk to each other. It's only able to interact with the MARSSA middleware. So let's say I cannot talk directly to you. I have to talk to Clayton. So if I die or something happens to me or a new version of me is available, I'm able to be plugged in and talk to Clayton. So there's no direct dependency between me and you. And then the deployment view. How will MARSSA actually look on a boat or on a ship or on a super yacht or on a Navy vessel? So it's a MARSSA as a private cloud composed of, let's say, 6 computers, being a rack server, a plug computer, and we'll have the high-speed bandwidth bus, which is able then to interact with, let's say, proprietary networks, being NVIDIA, Raymarine devices, and these things. So that's how MARSSA will look like. You have on board the boat, you have the MARSSA private cloud, a set of computers. You're able to control it with, let's say, an iPad, a Windows mobile phone, and you're able to also interact with proprietary systems. So the beauty of this is that if I install MARSSA on my boat now, and let's say in 10 years' time, iPad 15 comes out, you just go plug your iPad in and it's running. But if you go currently, let's say you go to some store in Malta or abroad and you go and you buy a nice Raymarine C series, then you're stuck with that in 10 years' time. Or you have to upload everything. With MARSSA in place, you just go buy another iPad and it's running in a matter of seconds. So now I'd like to introduce Clayton, who was running the demonstrator, and he was assisted by Amanda and Warren.
Thank you, Zach. Good morning to all. As Zach has rightly said, I'll be speaking a bit about the demonstrator. The demonstrator is actually an instance of the MARSSA reference architecture. So we've used the concepts which Zach and others within the MARSEC-XL team have built in order to describe systems, and we have actually described the requirements and the use cases of a small demonstrator board. So as you can see here in this slide, we've went from the reference architecture to a particular instance, and then we've implemented that instance in a physical boat, which some of you might have seen. All right, so we are adopting a community-based approach for the development of the demonstrator, and also, as you've seen in the previous slide, the process is, in each step of this process, there's a continuous loop. For each of these processes, we go through a validation and verification stage where we first decide that the requirements of the boat will be this. For example, the boat will be able to tweet its location, for example, or give its location on various front ends. After identifying this set of requirements, we went through the various stages to actually have that implemented on the physical boat. This is a picture of how the system actually looks from the inside and from underneath the cover. As you can see, we've used entirely cost components for this system. So if you have a look up there, the black box, that's a plug computer. It's a very low power computer, no display, everything running inside a small enclosure. The box next to it is a lab jack, a device which can be used to interface with various digital and analog inputs. And the rest is some power buses. We've got 12-volt bus and 5-volt bus to power the various COTS systems. An Ethernet switch, so that if we decide to add, it's not shown actually in the slide, if we decide to have multiple computers, the computers can talk between each other and so implement failover and maybe distribute the computing requirements between various computers. The remaining parts are basically a relay. It's a simple circuit to power the light systems, the underwater lights and the navigation lights. And we have also another circuit, the motor controller, which powers the actual propulsion system, the two motors, which you can see down there. It's basically an itinerary of the equipment I went through. I forgot to mention the GPS receiver. That's actually a very cheap GPS receiver we've bought from eBay, actually. So we also plugged in a temperature and depth sensor. It takes the water temperature, and we'll be able to show the depth of the underwater depth and the water temperature to the various front ends. We also have rudders to steer the boat, of course, and we have a feedback system so that we can know the direction of the rudders, so that the pilot who is navigating the boat can actually see on his front end what direction the rudders are actually steered. All right. This is a high-level view of MARSSA, which Zach has already shown a sample of this. So we have various stages, and as part of the implementation, we had to identify various technologies to put in each of these placeholders. As Zach has rightly said, MARSSA, the reference architecture, is a set of placeholders, which will tell you and will guide you. They will show you that you need this particular component to do this amount of stuff. So basically, you have to decide, you have to go through a process of choosing the technology to put inside that placeholder. And basically, for the lower part, for the hardware part, we've chosen a lab jack for the interfacing, and then the Dream plug as the computing power. Then we had to choose an operating system to run on top of that, and we've chosen Debian, an open source Linux distro. And the MARSSA backend is actually running, it's a Java-based implementation. I'm talking about the instance for the demonstrator. So we've chosen Java there, and basically it's running on an open source JVM as well. On top of that, we have defined a set of data types and interfaces which will enable other open source developers and maybe also system integrators to develop their own systems and plug them into the demonstrator. So if someone from the community decides that they want to add a new system or a new feature or develop an autopilot for us, for example, for the MARSSA community, they can use the data types and interfaces, which we have defined there, and through these interfaces, their new system will be able to interface with what we have already developed together with the community. On top of that, we have the systems which are running on the MARSSA backend, and we've basically got light control, navigation control, and rudder and motor control as well. And then there are the high-level systems, which basically use an aggregation of the lower systems, the ones in the green box. So basically, through the navigation and the other control systems, we can obtain location tracking of the boat. We can control the boat, of course, and all of this is done over web services. So if we decide to add an additional front end, it will be really easy, and even upgrading to a new version of, say, the next generation iPad or an Android tablet, it will be really easy to interoperate between the front end and the back end. This is a pictorial view of the various front ends which we have already developed. The first one is a jQuery-based web interface. This is actually hosted on the plug computer itself, so it's running entirely on the boat. So by using this, this front end, we can connect to the boat. It's via Wi-Fi, of course, so it's nothing, no rocket science there. And by simply opening a particular website, we can control the boat from within a website. We have also developed a Windows Phone front end. One of our team members, Amanda, and Ellen has developed the jQuery app. And Zach has developed an iPad front end. All of these front ends have basically the same features. All of them are able to do the same functions, but of course, as you can see, there's different technologies involved in each of this, from HTML to iOS and .NET for the front end Windows Phone. These are some other pictures of the technologies which we've used. We've got the LabJack for I/O, the DreamPlug, which I've described already, Linux, and Java. And if you can see the little Tux penguin in the bottom, that's the logo for GPSD. It's an open source project which we've used in our system to be able to interact with the GPS. All the sources which we've been working on are hosted on GitHub. It's a repository of open source projects, and if any of you would like to access that website over there, you can see all the projects from the back end to the front end which we've been working on. And basically we've put the MARSSA Java instance of the back end and also the various front end. All right, so Ellen will now discuss a bit about other instances of the MARSSA architecture.
So to conclude this presentation, I want to share our vision with you. What do we want to do with all this work, the demonstrator, all this code? What do we want? Where do we want to go? Basically, we want to have this on a super yacht. It was a logical case to choose a super yacht because the market is a large one, and well, it's way cooler than a ferry. So we opted for this choice. We think that it will look something like this. We will have a MARSSA private cloud hosting all the services, because MARSSA promotes a service approach where all the services are offered to the systems on board. So this MARSSA cloud will host, for example, the software and systems related to navigation, power management, automation, diagnostics, and also provide the processing power and the storage needed to host everything. Then in the peripheries, we may also have connection through web services to the public cloud, to the front ends, power layout, and also to a number of instruments, transducer and actuators around the boat. So everything is connected with this cloud and offered through service-oriented approach. But we have to start from somewhere to get there. So we chose these two projects, which we got funding from a national R&I investment hosted by MCST. The first project is Marlon. Marlon is a very simple project where we want to change lock keeping from paper into an electronic version. RealPromise is another project which is, stands for Real-Time Portable Reconfigurable Power Management Interpreter System. I still can't say that. But basically, it's a power management system which runs on MARSSA. It can be scaled up, scaled down according to the size of the boat, also for different types of boats, super yachts, maybe a cargo ship as well. It's, MARSSA allows this scalability and interoperability between different types of systems. Okay? So how do we make this possible? The MARSEC-XL work model allows us to make this possible. First, we have the demonstrator, which we are developing and doing research on within MIC in Malta. Whatever we learn, we push into STEC, where we are doing these two projects, the R&I projects, Marlon and RealPromise, and then we move to a further step, our vision to do it on a super yacht. This it's a sustainable way of going from an idea to the market, and it's working. So we're kind of in the middle right now. Okay, that's all from our side. Please log on marssa.org. Follow us on Twitter. We are there, and everyone is invited to join us and help out. Thank you very much.